In question number 31, Young's double slit experiment is conducted with a light of wavelength lambda. The intensity of the bright fringe is I0. Now, the intensity at a point where path difference is lambda by 4, that intensities we want to find. Here, I0 is equals to I maximum, and that is given by I plus 2 root I into I. So I0 will be equal to 4I. Now the path difference is lambda by 4. So the phase difference delta phi will be 2 pi by 4, that is equals to pi by 2. So I can be written as I plus 2 root I into cos pi by 2. But cos pi by 2 is 0, so I will be equal to 2I. So I will be equal to I0 by 2. So option 4 is correct option. In question number 32, in Young's double slit experiment, let beta be the fringe width and I0 be the intensity at the central bright fringe. At distance x from the central bright fringe, we want to find the intensity. Here, the delta phi is given by x d by capital D, or fringe width is given by x d by capital D. The phase difference will be 2 pi by lambda into delta or beta. So let us say A is the amplitude at the screen due to each slit. So I0 can be written as 4Ka square, where K is constant. For phase difference phi, let's say amplitude is A is equals to 2A cos of phi by 2. The intensity I is equals to Ka square is equals to 4K small a square into cos of phi by 2. So intensity I is equal to I0 cos square pi lambda into beta. So I0 cos square pi by lambda, and beta is xd divided by capital D. So I is equals to I0 cos square pi x upon beta. So option 3 is correct option. In question number 33, in Young's double slit experiment, the fringes are displaced by a distance x when a glass plate of refractive index 1.5 is introduced in the path of one of the beams. Then this plate is replaced by another plate of the same thickness, and the shift of the fringes is 3 by 2x. So in first case, x1 is equals to x, and second case the shift is 3 by 2x. We want to find the refractive index of second plate. Here the shift can be written as beta by lambda into mu minus 1 into t. Your beta and lambda will be same, so we can write x2 by x1 is equals to mu2 minus 1 upon mu1 minus 1. So x2 by x1 is, from this we can write 3 by 2 is equals to mu2 minus 1 divided by 1.5 minus 1, that is equals to 0.5. So mu2 will be equal to 1.75. So option 3 is correct option. In question number 34, in a double slit experiment, the wavelength of light used is 500 nanometer. A thin film of thickness 2 micrometer and refractive index 1.5 is introduced in the path of upper beam. As it is introduced in the path of upper beam, whole arrangement or whole dispersion pattern on the screen will be shifted on the upward direction. The location of the central maximum will shift in which direction and by how much amount? It will shift in upward direction. Now we want to find the amount. Here the change in path difference delta y will be equal to mu minus 1 into t into capital D by d. So delta y will be equal to mu minus 1, that is 0.5, into t, that is 2 micrometer, into d by small d. So this will be equal to 1 micrometer into capital D by small d. Now fringe width beta is given by lambda d by small d, that is equal to lambda is 500 nanometer. So this will be 5 into 10 power minus 7 meter. Take the ratio of beta and delta y. We will get delta y is equals to 2 beta. So the fringes will shift upward direction, in upward direction, and by 2 fringes. So option 3 is correct option. In question number 35, in Young's double slit experiment, an interference pattern is obtained on a screen by the light of wavelength 6000 angstrom coming from a coherent sources S1 and S2. At a certain point P on the screen, thick dark fringe is formed. We want to find the path difference S1P minus S2P. Here it is given that at point P, dark fringe is formed. So S1P minus S2P will be equal to destructive interference, so 2n minus 1 lambda by 2. Here n is equals to 3 and lambda is equals to 6000 angstrom. Put this value. So S1P minus S2P will be equal to 1.5 micron. So option 2 is correct option. In question number 36, in YDSC, fringes are obtained using a light of wavelength 4800 angstrom. One slit is covered with a thin glass of film of refractive index 1.4, and another slit is covered by a film of same thickness but refractive index 1.7. Thickness for both of them is same. By doing so, this central fringe is shifted to fifth fringe. So position of central will be at fifth right fringe. We want to find the thickness of the glass film. The change in path due to the first glass film is equal to T into mu1 minus 1, and change in path due to second one is T into mu2 minus 1. So the overall change in path difference will be equal to T into mu2 minus mu1. The path difference between central fringe and fifth bright fringe is equal to phi lambda, and that is equals to T into mu2 minus mu1. We want to find the value of T, so T will be phi into 48 into 10 power minus 7 divided by mu2 minus mu1, that is equals to 0.3. Simplify this, we will get T is equals to 8 into 10 power minus 3 millimeter. So option 4 is correct option. In question number 37, the Young's modulus, the Young's double slit experiment is performed with blue light and green light of wavelengths 4360 angstrom and 5460 angstrom. Y is the distance of fourth maxima from the central. Then we want to compare the distances of blue and green for fourth maxima. The fourth maxima is given by 4d lambda divided by small d. D and small d will be constant, so we can write y is directly proportional to lambda. So yb upon yg is equals to 4360 divided by 5460. From this we can write y for green is greater than y for blue. It is y for blue is less than y for green. So option 3 is correct option. In question number 38, in double slit experiment, the distance between two slits is 0.6 mm and the wavelength of source of light used is 4800 angstrom. The angular width we want to find of the dark fringe on the screen at the distance of 120 centimeter from the slits. For the first dark fringe, n will be equal to 1. The angular width of dark fringe is given by 2 into 2n minus 1 lambda by d. N will be equal to 1. So this will give us 2 into 4800 into 10 power minus 10 divided by d, that is 6 into 10 power minus 4. Simplify this, we will get answer 16 into 10 power minus 4 radian. So option 4 is correct option. In question number 39, the figure shows double slit experiment. P and Q are the two coherent sources. This point is P and this point is Q. It is n lambda and this is n plus 4 lambda. The path lengths of Py and Qy are given n lambda and n plus 4 lambda. Taking the central bright fringe as 0, what is formed at point Y? The path difference between P and Q is n plus 4 lambda minus n lambda, that is equal to 4 lambda. The condition to create bright fringe is path difference should be multiple of lambda. Here the path difference is multiple of 4 lambda. So at this point, fourth bright is created. So option 3 is correct option.